Okay, welcome back students. Let's continue with the chemical properties of the chlorine. In the previous class, we have taken the we were seeing the chemical properties of chlorine. So let's continue that particular thing only. And in the last class, we have studied about the action of chlorine with the litmus paper. Okay, so dry HCl gas has no action with the litmus paper, while the aqueous solution of HCl shows acidic nature. Now let's move further and see the reaction of HCl with metals. Reaction of HCl with metals. So in aqueous solution, it behaves as a strong acid, and the reason is that it fully ionizes in water. Okay, HCl fully ionizes in water, and hence it behaves as a strong acid, and the dissociation constant for HCl is Ka is equals to 1 into 10 to the power 7. So in aqueous solution we call HCl as hydrochloride acid. Okay, hydrochloric acid. Now ammonia is reacted with when ammonia is reacted with HCl, so ammonia is having basic nature and HCl is having acidic nature. So it will produce ammonium chloride, which is a salt. Okay, so neutralization reaction will be seen, and it shows that HCl is having acidic property. Now when we are going to see the reaction of HCl with metals, so in that, when HCl is reacted with active metals such as sodium, zinc, magnesium, iron, aluminium, etc., then let's see what is the reaction of HCl with it. So here, when HCl reacts with the metals like sodium, it will form salt, and hydrogen gas will be released out. When zinc reacts with HCl, it will form ZnCl2, salt of zinc, that is zinc chloride, and H2 will be released out. Similarly, when reacted with magnesium, HCl will produce magnesium chloride and H2 will be released out. Iron, it will produce FeCl2, ferrous chloride, and H2 will be released out. Similarly, with aluminium, it reacts with HCl to produce Al2, sorry, 2AlCl3 with 3H2 gas. Okay, so this is the reaction of HCl with metal. It forms the salt with the metals, and hydrogen gas has been released out when it reacts with metals. The next is the oxidation of HCl. So HCl oxidizes by the atmospheric oxygen in the presence of cupric chloride. When HCl is reacted with oxygen to for undergoing oxidation, it is done under the presence of cupric chloride. Okay, and at 723 Kelvin temperature, and here what will happen, water and chlorine gas will be released out. So this is the oxidation of HCl. HCl as an reducing agent. How HCl is behaving as an reducing agent? Reducing agent. So it acts as a reducing agent because it can oxidize by chlorine it is oxidized to chlorine by strong oxidizing agents like magnesium dioxide, potassium permanganate, and potassium dichromate. Okay, so when HCl reacts with magnesium dioxide, which is one of the good oxidizing agent, it will produce magnesium chloride, and the hydrogen will oxidize to water, and Cl2 will be released out here. So here 4Cl MnO2. Okay. Next 2KMnO4, when potassium permanganate reacts with HCl, it will produce potassium chloride, magnesium chloride, water molecules, and chlorine gas will be released out there. Next, when it is reacted with potassium dichromate, then it will form potassium chloride, chromyl chloride, water, and chlorine. Okay, and chlorine. Next, its reaction with fluorine. Its reaction with fluorine. Okay. So fluorine will displace the chlorine from the hydrochloric acid to form hydrofluoride. Okay, hydrochloric acid. And bromine and iodine have no action on the hydrochloric acid because they cannot displace chlorine from the hydrochloric acid. Okay. Next, the reaction with weak salts. Okay, weak acids, action with salts of weak acids. Okay, so such as example K2CO3, which is a salt of carbonic acid, that is a weak acid. Here the HCl will react and form strong salt, that is acidic salt, that is KCl H2O. Sorry, neutral salt will be formed out here. Okay, with the reaction of weak salts, salts of weak acids. Okay, NaHCO3. It is also a salt of carbonic acid only, sodium hydrocarbonate. When react with the hydrochloric acid, they will produce neutral salt, that is NaCl, water, and carbon dioxide gas will be released out here. Sodium sulfite 2HCl gives 2NaCl plus H2S gas. Okay, sodium sulfite plus 2HCl, it will give sodium chloride plus H2O plus SO2 gas will be released out. Okay, so these are some of the reactions for the actions of reaction of HCl with the weak salts of weak acids. Okay, now reaction of HCl with the metal salts. So let us say see the reaction of HCl with the lead acetate. So when lead acetate reacts with HCl, there a white precipitate, that is lead chloride, will be produced out there. Okay, white precipitate, that is lead chloride, is been produced out with acetic acid. With acetic acid. With silver nitrate, HCl when react, it forms silver chloride plus HNO3, where silver chloride is also white precipitate. Then further, when this silver chloride is reacted with ammonium hydroxide, it produces sodium, sorry, silver di diammonia silver chloride, okay, diammonium silver 1 chloride, diamine, sorry, the name is diamine silver 1 chloride, silver 1 chloride, and water will be released out here, and water will be released with mercurous nitrate. It reacts with mercurous nitrate, that is Hg2 NO3 twice, to form Hg2 Cl2, that is white precipitate, mercurous chloride, okay, plus 2HNO3. So these were the reaction of HCl with different metal salts. And the last is the formation of aqua regia. Formation of aqua regia. So what is aqua regia? Aqua regia is the mixture of 3 part of HCl with 1 part of nitric acid to form nitrosyl chloride, water, and chlorine is being released out. Okay. Here, aqua regia can easily dissolve the gold also. Okay, it can easily dissolve gold, which generally does not react with the acids. So, or gold plus these 3 chlorine atoms, they will form aurum chloride. Okay, auric chloride. Sorry, auric chloride, that is soluble. Okay, that is soluble. So hence we can easily dissolve uh, gold also, which is a noble metal, in the aqua regia. Now uses of HCl. What is the uses of HCl? Number one, dyeing, calico printing. Okay, for the dyeing purpose of the calico printing, and tanning industry. For the tanning of leather, the HCl acid is being used. Next, manufacture of glucose. HCl is used for manufacture of glucose by hydrolysis of starch, by hydrolysis of starch. Third, the preparation of aqua regia. For the preparation of aqua regia. Fourth, an important reagent in the laboratory. An important reagent in the laboratory, used in medicines also. Okay, it is widely used in medicines also. So these are the different uses of HCl. Now let's see the oxo acids of halogens. So halogens generally form the oxo acids in the formula of HOX, HXO2, HXO3, and HXO4. Okay, so these are the different oxo acids of the halogens. So oxidation state for one column, second column for fluorine, okay, second column for the acid's name, then the fluorine, then chlorine, then bromine, and the last is your iodine. Okay, so here we will discuss about the oxo acids of the halogens. So let's start the oxo acids of halogen. So oxidation state plus 1. For oxidation state plus 1, halic acids will be formed. Okay, halic acids will be formed that are termed as hypohalous acid. Hypohalous acid. Here HFO is formed. Hypofluorous acid. Hypofluorous acid. HClO. Hypochlorous acid. HBRO. Hypobromous bromous acid. HIO. Hypoiodous acid. Next for the oxidation state plus 3. Halic 3 acids. Halic oxidation number 3 acid. They are termed as halous acids. Halous acids. So here fluorine does not form halous acids. HClO3. HCl, sorry, HClO2. HClO, that is chlorous acid. Chlorous acid. Okay, it is only formed. Then plus 4 halic 5 acid. Halic 5 acid, and it is termed as halic acid. Halic acid. So the first acid in this group is HClO3, that is chloric acid. HBrO3, bromic acid. HiO3, iodic acid. Last is the plus 5, sorry, not plus 5, it is plus 7. Last is the plus 7 oxidation state where halic 7 acid is formed, that is perhalic acid. Perhalic acid. So in this HClO4 perchloric acid. Perchloric acid. HBrO4 perbromic acid. HiO4 per iodic acid. Okay, so this will be the different kinds of oxo acids which is formed from the halogens. So let's see some of the structures for the important acids. That is, first is the HOCl, hypochlorous acid. So hypochlorous acids structure is HCl. Okay, this is the structure, band structure it is. Then chlorous acid. Okay, chlorous acid. So chlorous acid structure is Cl, OH, Cl double bond O. Then next is the this is hypochlorous acid. Chlorous acid. And the last is double bond O, double bond O. This is chloric acid, chloric acid, and the last is perchloric acid. Okay, perchloric acid. So the perchloric acids structure is this perchloric acid. Okay, this is the three structures for, these are the different various structures for uh, oxo acids of chlorine. Now let's move. The acidity will decrease. Okay, the acidity will decrease as the number of oxygen atoms is increasing there. Sorry, the stability will increase, and naturally what will happen, the stability will increase, and hence we will see that weak conjugate base. Okay, strong acid has a weak conjugate base. Okay, so we will say that as perchloric acid is having the highest stability, it means that it will naturally easily release this H plus ion. So it is one of the strongest acid. Okay, it will be the strongest acid among the different oxo acids of chlorine. Okay, and while the hypochlorous acid will be the weakest acids among the other oxo acids of chlorides. Okay, because it is having less stability and it will not release this H plus ion as soon as possible. Okay, next is the interhalogen compounds. Interhalogen compounds. So interhalogen compounds are formed. What are the interhalogen compounds? The compound containing two or more halogen atoms are called interhalogen compounds. Okay. So generally the number of the atoms per molecules increases, and the iodine 7 fluoride should have maximum number of atoms present because the ratio of the radii is maximum there. Okay, the neutral interhalogen. There are two types of interhalogen compounds. That is, first is the neutral interhalogen compounds, and the second is the interhalogen anions and cations. Okay, so in the neutral interhalogen compounds, neutral interhalogen compounds, we will see ICl, BrF5, IF5. Okay, pentafluorides, then IF7, etc. These are the neutral interhalogen compounds, while some of the interhalogen anions and cations will also be present there. Okay, interhalogen anions and cations will also be present there. So here the interhalogen anions and cations can be have the following structure: X X dash X X thrice dash X X 5 time dash X X 7 time dash. Okay, so these are the different interhalogen compounds. So for interhalogen compounds, let's see the examples here. So here for XX dash, it will be ClF, chlorine fluoride, which is a colorless gas. Then, which is a colorless gas, chlorine fluoride. Bromine fluoride, pale brown colored gas, pale brown colored gas. Then iodine fluoride, very unstable, okay, highly unstable, and therefore we will add a star here in order to show its instability. BrCl, bromine chloride, it is also a gas. And the last and the next is iodine chloride, ICl, which is ruby red solid, ruby red colored solid. Alpha form will be brown red solid, and beta form also will exist there. And the last is IBr, that is iodine bromide. It is a black colored solid. Black colored solid. Next, ClF3, that is chlorine trifluoride. It is also a colorless gas. Colorless gas. Bromine trifluoride, yellow green liquid. It is yellow green liquid. Yellow green colored liquid. Then IF3. It is also highly unstable, but it is yellow colored powder. Yellow color powder. And the last is ICl3, orange colored solid. It is a orange colored solid. Next is the chlorine pentafluoride. It is also a colorless gas. Next, bromine pentafluoride. Bromine pentafluoride, colorless liquid. Colorless liquid. And iodine pentafluoride, colorless gas, but solid at 77 Kelvin temperature. And the only compound in the XX-7 is iodine heptafluoride. Okay, iodine heptafluoride, which is also a colorless gas only. Colorless gas. So these are the different uh, interhalogen compounds, okay, with their physical state and their colors. Some of the ions, okay, some of the interhalogen ions I am showing you, such as ICl2 minus, IBr2 minus, BrCl2 minus, ICl4 minus, BrF4 minus, IF4 plus, ClF4 plus, means positive ions and negative ions, that is cations and anions. Both are formed by interhalogen compounds. BrF6 plus minus, IF6 plus, BrF6 plus, okay, so etc anions will be there. So these were about the chemistry of the different interhalogen compounds. Okay, now let's talk about their structure, which kind of structures they possess. So generally the XX3 dash compounds will be having trigonal bipyramidal. Okay, they will be having trigonal bipyramidal. If I am taking a example for chlorine trifluoride, so there the chlorines 2 lone pair and one fluorine will be forming same, will be on the same plane, forming a triangular structure. One fluorine atom at the top and one fluorine atom at the bottom will be there. It will be having trigonal bipyramidal geometry. Next is your IF5. Okay, means XX5 dash. Here we will be taking example for IF5, where it is having square bipyramidal, 4 fluorine atoms forming a square, one lone pair at bottom and one fluorine at the top, like this. Okay, so they will be having square pyramidal structure, XX5 dash. Next is the XX7 dash. It will be having pentagonal bipyramidal structure, I F F F. The fluorine is attached in such a way that they are forming pentagonal structure there. like this, and one fluorine will be attached at the above and one fluorine at the below. So they will be having pentagonal bipyramid. Okay, so this will be the structures for the different interhalogen compounds. So we will continue with the group 18 elements in the next class, and will conclude this particular chapter, that is P block element, in that particular class. So thank you for watching this video. We will continue the class in the next class.